Imagine building a massive cathedral that stands for 900 years, without blueprints, electricity, or modern machines. Now imagine modern builders struggling to keep a concrete plaza from cracking in just 5. Chapter 1. The Age Before. Measurements. How medieval craftsmen built with pure skill. If you were to walk into a medieval construction site, the first thing you'd hear wouldn't be the clang of metal machines or the hum of engines. You'd hear voices, masters shouting instructions, apprentices repeating them, stones being tapped into place with the slow confidence of people who didn't just work with their hands, they thought with them. Because medieval craftsmen operated in a world before standardized measurements. No laser levels, no digital blueprints, not even the measuring tape we toss casually into a toolbox today. And yet, they built some of the most enduring structures humans have ever created. Imagine a master mason in 1250 standing before the rising walls of a cathedral. He doesn't pull out an iPad or even a notebook. Instead, he looks up, squints against the sunlight, and reads the stone like a musician reads a score. The curve of an arch, the angle of a buttress, the height of a tower, these weren't just numbers to him. They were shapes, rhythms, and relationships he had committed to memory through years of apprenticeship. And this is the first clue to why medieval craftsmen were, in many ways, smarter than modern builders. They learned architecture through the body, not just the mind. A medieval craftsman didn't study geometry. He performed it. He didn't memorize measurements. He felt them. An apprentice began training around age 12, working side by side with a master who expected absolute attention. For 10 years, the apprentice would watch his master lay stones so precisely that even a sheet of parchment couldn't slide between them. He'd learn to judge thickness by touch, alignment by eye, and structural load by instinct. Skills honed through repetition so intense they became second nature. Modern builders rely heavily on tools to tell them what's level, what's straight, what fits. Medieval craftsmen relied on a lifetime of deep, internalized understanding. Even something as simple as cutting a wooden beam required astonishing skill. Without mass-produced planks, every beam had its own shape, weight, and grain. Craftsmen learned to read a tree like a map, knowing which part would split, which part would hold, and which part would anchor a roof for centuries. Knowledge was passed down, like sacred wisdom. Today, most construction knowledge is written, diagrams, manuals, engineering software. In medieval times, it was guarded, embodied, and almost ritualistic. Guilds, exclusive brotherhoods of craftsmen, protected their methods fiercely. They passed them to apprentices only after years of loyalty and service. To become a master meant not just knowing how to build, but showing creative genius. You had to produce a masterpiece, a physical demonstration proving you had absorbed the wisdom of generations. This kind of intelligence, slow-grown, experience-based, intuitive, is something modern construction rarely cultivates. Problem-solving without calculators. Consider this. Medieval builders raised cathedrals hundreds of feet high without modern mathematics. They knew how a wall strained under weight. They felt how much give a timber frame offered. One famous story tells of a mason who paused the construction of a bell tower for 2 days because, while walking past the lower arches, he sensed a faint vibration under his boots. No blueprints told him he was right. No device confirmed it. But his intuition saved the tower from collapsing years later. Cliffhanger for next chapter. But skill alone wasn't the secret. Medieval craftsmen didn't just build smarter, they built with materials modern builders barely understand. And those materials are the real reason their creations survived 1,000 years. Chapter 2. Stone that breathes. The forgotten materials. Modern builders don't understand. Walk up to a medieval church wall and place your hand on the stone. You'll feel something surprising, cool, yes, but also slightly alive. Not literally, of course. Stone was treated like a personality, not a product, to a medieval mason. 2 stones from the same quarry weren't identical. One might have a hidden weakness, another might ring differently when tapped. Yes, ring. Masons carried small hammers for this exact purpose. They struck a stone lightly and listened. They didn't force materials to behave. They worked with them. This partnership between builder and stone is a major reason medieval structures survived earthquakes, storms, and centuries of climate changes. Lime mortar, the magical glue modern builders forgot. If you told a modern contractor to build a house with lime mortar instead of cement, many would look at you like you'd suggested rebuilding the pyramids with chewing gum. But lime mortar, soft, flexible, self-healing, was the unsung genius of medieval construction. Let's compare. Cement, modern, hardens fast, doesn't breathe. Traps moisture inside walls, fails suddenly. Lime mortar, medieval. Flexes with the building, breathes out moisture. Modern concrete, by comparison, is strong, until the moment it isn't. When concrete fails, it fails all at once. Medieval lime fails slowly, giving masons time to see, hear, and repair issues. It's like comparing a rigid plastic ruler to a leather belt. One snaps, the other bends. Timber frames built like skeletons. Step into a medieval timber hall and look up. The beams curve like ribs, forming a structure that feels almost biological. This wasn't decorative, it was intelligent engineering. Medieval builders chose timber based on the age of the tree, the season it was cut, the direction of the grain. Today we grind logs into perfectly rectangular planks. Easy to stack, fast to install, but often weak where strength is needed most. Medieval carpenters built frames that mimicked bones, joints, and tendons. Structures breathed, flexed, and carried weight the way bodies do. Roofs that lasted centuries. Medieval roofs weren't just weather protection, they were masterpieces of material wisdom. Take lead roofing, for example. Medieval craftsmen used sheets of lead that could expand, contract, and reseal themselves. Modern roofing materials can tear, rip, or become brittle after a few decades. Medieval roofs survived for hundreds of years. Some still do. Thatch roofing, surprisingly, could last 40-60 years when installed correctly. The secret? Medieval thatchers understood airflow, moisture escape, and layering so well that rot struggled to form. Cliffhanger for next chapter. But materials are only half the story. How did medieval craftsmen build enormous structures without calculators, blueprints, or formal engineering degrees? The math they used will surprise you because much of it wasn't written anywhere. It existed only in the minds of the builders. Chapter 3. Cathedrals. Without calculators, the hidden math and engineering genius of medieval builders. If you've ever stood inside a towering medieval cathedral, you've probably felt that small, stunned moment where your brain whispers, "How on earth did humans build this? The soaring arches, the impossible height, the perfect symmetry. It all seems too precise for a time without calculators or engineering software." Yet medieval craftsmen did it, and they did it with a kind of mental geometry modern builders rarely use anymore. Because here's the surprising truth. Medieval builders weren't just good at math, they were living inside it. Geometry was a language, not a formula. For a medieval master mason, shapes weren't abstract ideas written in a book. Shapes were the foundation of the world. Circles, triangles, and squares weren't just symbols. They were divine patterns woven into nature. Builders believed that by using these shapes, they weren't just constructing walls. They were aligning with the proportions of the universe itself. So instead of calculating with numbers, they constructed geometry directly on the ground. Picture this. No equations, no blueprints, just pure spatial intelligence, the secret of the rope and peg system. This simple method allowed masons to create perfect right angles, determine wall thicknesses, plan window placement, plot ribbed vaults. Think about that. While modern builders rely on rulers, lasers, and level sensors, medieval builders use nothing but the earth, string, and a deep internal understanding of proportion. Arches that hold themselves up. One of the most brilliant medieval engineering secrets was the arch. Today, arches are optional decorative flourishes, but here's the genius. Medieval masons designed these arches without calculating load-bearing formulas. They relied on experience, pattern memory, generational knowledge. A master could glance at the curve of an arch and know, instinctively, whether it would stand. That kind of judgment is impossible to program into a machine. Flying buttresses, the medieval cheat code. Flying buttresses look like elegant wings holding up a cathedral, but they weren't built for beauty. They were engineering weapons. They redirected outward pressure from the heavy roof and walls, channeling it safely to the ground. Modern engineers calculate stress forces using computers. Medieval builders felt the pressure in the stones beneath their hands. The human calculator. Every cathedral had one master mason who acted as architect, mathematician, engineer. If he died mid-project, it was a crisis, because no one had written down his methods. His brain was the blueprint. The surprising result. And here's the twist. Many medieval structures are still standing straight and strong today, while modern buildings with reinforced concrete are crumbling after just 40-70 years. Why? Because medieval masons didn't think like calculators. They thought like craftsmen who understood how forces flowed, how materials moved, how buildings breathed. Their tools, simple, wooden, handmade, were designed to amplify human intelligence. In the next chapter, you'll discover why their low-tech tools made them smarter than many workers using high-tech tools today. Chapter 4. Tools that were simpler, yet smarter. If you could walk into a medieval workshop, you wouldn't find power drills, laser levels, or hydraulic lifters. You'd find wooden mallets, iron chisels, hemp ropes, plumb bobs, hand-forged saws, and cranes spun by nothing more than human muscle. And yet, with these simple tools, medieval craftsmen achieved precision and durability that modern builders, surrounded by advanced machines, often struggle to match. Why? Because medieval tools were designed for a different kind of intelligence. They didn't replace the craftsman's mind, they activated it. A simpler tool demands a smarter worker. Let's start with the iconic medieval plumb bob, a weight on a string, nothing more. But in the hands of a master mason, it became a surgeon's scalpel. A plumb bob teaches you balance, gravity, and alignment. You learn to watch the slightest sway, to feel air currents shift, to understand how a wall leans, not by numbers but by instinct. Modern builders use a laser level. It's accurate, yes, but it asks nothing of the builder. It does the thinking for them. Medieval craftsmen used tools that forced them to pay attention. A hand plane required understanding wood grain. A chisel required listening to the sound of stone. A hammer required rhythm, control, and muscle memory. The tool didn't carry the skill. The person did. Tools were extensions of the body. Modern tools often distance workers from the material. A bowsaw told you through resistance if you were cutting against the grain. A mason's chisel communicated feedback like a living wire, connecting man to matter. Even measuring tools were minimal. Calipers, dividers, chalk lines, the mason's square. These weren't shortcuts, they were guides. They preserved the builder's sense of proportion rather than hiding it. When modern builders say, the tool slipped, medieval builders would laugh. Their tools couldn't slip. Why did they work so well? Because medieval builders understood leverage, friction, counterweight, and rotational force intuitively. Medieval cranes worked with human senses, balance, rhythm, and cooperation. Sharpening tools was an art of its own. A medieval craftsman didn't just use tools, he made them. He forged his own chisels, shaped his own axes, tuned his own saws, and carved his own handles to fit his grip perfectly. This created a relationship modern workers rarely have. A craftsman didn't adapt his work to the tool, he adapted the tool to himself. Slow tools create fast minds. Here's the paradox. The simpler the tool, the sharper the craft. Because medieval tools required concentration, muscle memory, sensory awareness, careful judgment. And that's why medieval craftsmanship has a soul modern machinery cannot replicate. A modern wall can be built quickly. A medieval wall had to be understood before it could be built. That difference changes everything. Cliffhanger for next chapter. But tools and technique weren't the only things that made medieval work extraordinary. In the next chapter, we explore the mindset, the code of honor, pride, and precision that pushed craftsmen to create buildings meant to last longer than their own lives. Chapter 5, The Human Touch. Why medieval work was more precise than modern construction. If you asked a medieval craftsman who he was, he wouldn't say, "I'm a worker." He'd say, I am a mason, a carpenter, a thatcher, a smith. Not a job, not a paycheck, an identity. This is the first and maybe the biggest difference between medieval construction and modern building. In craft wasn't something they did, craft was who they were. And when your work becomes a part of your soul, precision is not optional, it's inevitable. But medieval builders lived in a world where a cathedral might take 60, 90, even 120 years to finish. The man who laid the foundation stones knew he would never see the roof completed. Instead, he was building for the next generation. Imagine the mindset that creates. A medieval craftsman could point to a wall he built and say, "My grandson will see this." Guild oaths, skill. Bound by honor. Guilds were more than trade unions. They were ethical communities with strict codes of conduct. A craftsman swore an oath when entering a guild, promising to work honestly, maintain the highest standards, protect the secrets of the craft. If a craftsman cheated or rushed a job, he wasn't just fired. He was shamed, fined, or expelled. Losing your guild membership meant losing your identity and livelihood. Contrast that with modern construction, where cutting corners is often tolerated if it saves money. In the medieval world, the only acceptable standard was excellence. Builders worked slowly because they worked precisely. Modern construction culture equates speed with profit, but medieval craftsmen equated speed with weakness. A rushed wall might crack, a hasty joint might fail, a sloppy beam might sag. So they took their time, not lazily, but purposefully. A medieval mason might spend an entire morning adjusting a single keystone. A carpenter might shape a beam for a day just to ensure it fit perfectly into a mortise and tenon joint. And nothing was more humiliating than producing something crooked, weak, or flawed. There are stories of masons dismantling their own work when it didn't meet their standards, even when no one else would have noticed the mistake. A slightly misaligned arch, a poorly squared stone, a joint that creaked, they would redo it. Because their signature wasn't ink. Their signature was the building itself. Craftsmanship was sacred. For many builders, working on a cathedral or church wasn't just a job, it was a service to God. Stone was shaped with reverence, wood was chosen with intention. Every detail carried symbolic meaning. Even secular buildings were made with care because a poorly built structure threatened lives. Hand-cut joints still fit tightly, roofs still shelter towns, arches still span rivers. Their accuracy wasn't produced by machines. It was produced by attention, dignity, pride, and patience. This kind of precision simply can't be mass-produced. It only grows in the hands of people who care more about craft than convenience. Cliffhanger for the final chapter. But all this raises one final question. If medieval craftsmen were so skilled, so wise, and so precise, what happened to that knowledge? In the last chapter, we'll explore what the modern world forgot, and what we can still learn from the genius of the Middle Ages. Chapter 6, What Modern Builders Forgot. And what medieval craftsmen can still teach us. Walk through any old European town and you'll notice something strange. The oldest buildings, those built with hand tools, natural materials, and no formal engineering, are often the ones still standing strongest. Meanwhile, modern structures less than 50 years old already show cracks, leaks, rust, and decay. How did this happen? How did builders with no electricity, no machines, and no engineering degrees create structures that outlast our most advanced designs? The answer isn't simply better materials or more time. The truth is deeper. Modern construction forgot the philosophy of craftsmanship. The world became faster, but not necessarily smarter. Modern society rewards speed, convenience, and profit. Construction is scheduled like a race. Deadlines stacked on deadlines, budgets squeezed to the last nail. Buildings are assembled like fast food, quickly, cheaply, uniformly. But medieval builders didn't operate in a world of rushing clocks. They worked in a world of seasons, tradition, and legacy. When your goal is to finish fast, you choose materials that cure quickly. When your goal is to finish cheaply, you choose materials that are mass-produced. But when your goal is to build something meant to last 500 years, you choose differently. You build differently. You think differently. You value differently. This is the great divide between then and now. The loss of hands-on intelligence. In the Middle Ages, builders used their bodies as instruments of measurement. Their eyes became levels, their hands became calipers, their intuition became engineering. They didn't outsource judgment to machines, they cultivated it within themselves. Today, machines do the precision work. Laser levels tell us what's straight. Calculators tell us what's possible. Software tells us what will stand. We've gained convenience. But we've lost the depth of understanding that comes from doing things by hand. Medieval craftsmen didn't need to check their work. They felt it. Materials that asked to be understood. Lime mortar, natural stone, clay tiles, timber joints. These materials required knowledge, patience, and respect. They moved with the seasons, expanded with moisture, aged with grace. In modern materials, concrete, plastics, synthetic insulation are faster, cheaper, and easier. But they age poorly. They resist repair. They crack, rust, mold, or crumble. Medieval builders weren't fighting nature. They were cooperating with it. That philosophy created buildings that feel alive because they are alive, then moves on. Another crew takes over. No one leaves their mark. The goal isn't to abandon modern technology and rebuild everything like it's 1250 AD. The lesson is subtler and more important. Medieval craftsmanship teaches us that intelligence grows from presence, patience, and pride. It teaches us that the best buildings are repairable instead of disposable, built slowly instead of rushed, made with care instead of mass-produced, designed for generations instead of decades. And maybe most importantly, medieval builders remind us that beautiful, lasting work comes from humans who care deeply about what they make. The final answer to the title. So were medieval craftsmen really smarter than modern builders? In many ways, yes. Not because they knew more formulas, not because they had better tools, but because they understood the heart of construction. A building isn't just a structure. It's a relationship between material, maker, and time. And medieval craftsmen honored that relationship with every stone they shaped. Their message is simple. Build as if the future is watching.